The golden proportion is one of the most interesting topics in mathematics. It is related to a variety of topics. In this video, we will talk about the relation between the golden proportion and famous mathematicians like Euclid, Leonardo da Vinci, Fibonacci, or Pythagoras. Of course, we will also talk about geometry, rectangles, triangles, and spirals. Art is going to be part of this talk: sculpture, architecture, design. We will finish talking about nature, the human body, animals, and plants. This is Luca Pacioli. He wrote a book called Divina Proporzione, published in 1509. The subject was mathematical and artistic proportion, especially the mathematics of the golden ratio and its applications in architecture. Leonardo da Vinci drew some illustrations. This is Euclid of Alexandria. He provided the first known definition of the golden ratio in his famous book Elements. A straight line is said to have cut in extreme and mean ratio when the whole line is to the greatest segment, so is the greater to the lesser. This segment has been cut using this definition. The whole segment A plus B is to the greatest segment A, so is the greatest segment A to the lesser segment B. This number, which is an irrational number, is denoted by the Greek letter phi. It is very easy to obtain this point geometrically. First, construct a perpendicular segment at point B whose length is the half of the original segment AB. Then, draw the corresponding right-angled triangle. Finally, draw two arcs, this one and this other. This point divides the original segment into the golden ratio. As we said, the golden ratio is an irrational number. This means, among other things, it is a decimal number that doesn't terminate nor end with a repeating sequence. The golden ratio admits some interesting representations, for example, using square roots or using continuous fractions. Of course, these representations are infinite. Here you can see the value of these representations till the step we have written. Till this step, they are very good approximation to the exact value. This is Leonardo Pisano, most well known as Fibonacci. He is very famous for his book Liber Abaci, where he describes the well-known Fibonacci sequence related to the growth of rabbit population in an idealized way. A newly born breeding pair of rabbits are put in a field. Each breeding pair mates at the age of 1 month, and at the end of the second month they always produce another pair of rabbits. The rabbits never die, but continue breeding forever. Let's see this step by step. At the end of the first month, they mate, but there is still only one pair. At the end of the second month, they produce a new pair, so there are 2 pairs in the field. At the end of the third month, the original pair produced a second pair, but the second pair only mate without breeding, so there are 3 pairs in all. At the end of the fourth month, the original pair has produced yet another new pair, and the pair born 2 months ago also produced their first pair, making 5 pairs, and so on. This is the sequence of Fibonacci: 1, 1, 2, 3, 5, 8, 13. As you can see, each number is the sum of the two preceding ones. For example, 1 plus 1 equals 2. 5 plus 8 equals 13. 21 plus 34 equals 55. 89 plus 144 equals 233. What is the relation between the golden ratio 5 and the Fibonacci sequence? Remember the Fibonacci sequence and the value of the golden ratio 5. If you make the division of two consecutive terms of the Fibonacci sequence, you can observe that the quotient converges to the golden ratio. For example, 1 over 1 equals 1. 5 over 3 equals 1.6 repeating. 34 over 21 equals 1.619, or 233 over 144 equals 1.618055, which is a very good approximation of the golden ratio. This is Pythagoras. His life is clouded by legend. He founded a school at the south of Italy. The five-pointed star, or pentagram, was one of his symbols. This star can be described in a regular pentagon. We can distinguish different segments: the diagonals in red, the side of the pentagon in blue, the side of the star in green, or the side of the inner pentagon in yellow. All these segments keep the same proportion and obtain the golden proportion. The pentagram is very related with mysticism and symbolism. It has been related with religion or magic. It has been used as a power symbol or a symbol of authority. It is also used to represent famous people. The five-pointed star appears in a lot of national flags like Cuba, Morocco, or the United States of America. Related to the geometry, the most outstanding figure is the golden rectangle. It is a rectangle whose size, length are in the golden ratio. Here you can see how to obtain a golden rectangle starting with a square. The golden rectangle has very interesting properties. If you remove a square from a golden rectangle, you obtain a new small golden rectangle. If you add a square to a golden rectangle, you obtain a new big golden rectangle. If you place two golden rectangles of the same size in this position, the diagonal of the first rectangle passes through the vertex of the second rectangle. Even more, if you draw the diagonal of the second rectangle, this point is called the God's eye, and it is related to the next concept. As we said before, if you remove a square from a golden rectangle, you obtain a new small golden rectangle. Then we can do the same using this new golden rectangle. And we can continue doing this one and again. Taking these squares as a reference, we can draw quarter of circumference, obtaining a spiral. called the spiral of Dürer or the golden spiral. We can obtain the same result if we use a golden triangle, which is an isosceles triangle whose side lengths are in the golden ratio. As before, we can draw smaller golden triangles inside the golden triangle as the figure shows. The golden ratio also appears in architecture, for example in the Parthenon, as well as elements in its front, and elsewhere are said by some authors to be circumscribed by golden rectangles. However, other scholars deny that the Greeks had any aesthetic association with golden ratio. Other examples in architecture are the Eiffel Tower in Paris, France, where the different flats keep the golden proportion. Notre Dame Cathedral in Paris, France, where the golden proportion appears in the three parts of the front. The headquarters of the United Nations in New York City, USA, whose building is composed by three golden rectangles. The golden ratio has been used a lot in painting due to the beautiful proportions it produces. For example, Leonardo da Vinci used it in La Gioconda or Mona Lisa. Recall that the book Divine Proporzioni by Luca Pacioli contains drawing by Leonardo, so he knew the golden proportion. Other examples in painting are L'Era Atomica by Salvador Dalí. Here you can see a sketch of the paintwork. The Birth of Venus by Sandro Botticelli, where the golden proportion is used in Venus' body. The golden ratio has been used in design due to its nice proportion. The golden rectangle is the pattern on credit cards or identity cards. The golden spiral, which is inside the golden rectangle, appears in iPods, ebooks, posters, webs like Twitter, packs of cigarettes, and so on. This is Vitruvius. He was a Roman architect and engineer in the 1st century BC. He wrote a book called De Architectura, where he discussed the proportion in architecture and the human body. This led to Leonardo to draw his famous drawing, The Vitruvian Man. In this book we read, in the human body, the central point is naturally the navel. For if a man will place flat on his back with his hand and feet extended and a pair of compasses centered on his navel, the fingers and toes of his two hands and feet will touch the circumference of a circle described therefrom. And just as the human body uses circular outline, so too a square figure may be formed from it. For it, we measure the distance from the soles of the feet to the top of the head, and then apply that measure to the outstretched arms. The breadth will be found to be the same as the height as in the case of plane surfaces, which are perfectly square. The ratio between the length and the side of the square and the length of the radius of the circumference is approximately the golden ratio. In Vitruvius' book, other ratios also appear with different parts of the human body, that are approximately the golden ratio. The relation between the consecutive phalanges, the relation between the hand and the forearm, the shape of the ear, the proportion between the consecutive teeth. Something similar occurs with some proportions in the face that make it more attractive, when the proportions amount the distance between the eyes, the length of the mouth, or the distance between the eyes and the mouth are approximately the golden proportion, the face seems to be more beautiful. Here you have some examples: Britney Spears, Angelina Jolie, David Beckham, Megan Fox, Tom Cruise, and even myself. There are a lot of animals whose body also contains the golden proportion. Snails have a golden spiral shape because they can move towards outside when they grow up. The different parts of an ant keep the golden ratio. Starfishes usually have a five-pointed star shape. The golden ratio appears in other aspects of nature. For example, most of the galaxies and all the twisters look like a golden spiral, due to the spin of its elements. Even in the center of a twister, we can see a structure similar to a pentagon, pentagonal flower. In botany, phyllotaxis is the arrangement of leaves on a plant or petal on a flower. It is very common finding flowers with one petal, two petals, three petals, 5, 8, 13, 21, 34. These are terms of the Fibonacci sequence. This is related to the golden angle. If we take a segment cut into the golden proportion and we bend it to obtain a circumference, we get a golden angle. (137.5°). Using this angle, leaves on a plant, petals on a flower, or seeds on a plant are distributed, optimizing space. In this series of pictures, we can see several distributions. The greater the number of seeds, the more recognizable the figure. It is a sunflower. Seeds on a sunflower are uniquely related to the Fibonacci sequence and the golden angle. The seeds are placed forming golden spirals. There are 55 spirals of this size. There are 34 spirals of this other size. Or there are 21 spirals of this size. 21, 34, 55 are terms of the Fibonacci sequence. Here you can see the same structure, golden spirals, in another different plants, Romanesco, cactus, or cauliflower. Finally, we can convert the golden ratio in music. Each decimal digit is converted into a note of the musical scale. Using this, we can listen how the golden ratio sounds. Here you have a very good arrangement.